This is the JSOWC, where a Navy carrier strike group turns precision into punishment. The Houthis never saw it coming until everything started exploding at once on March 28th. F-18s from the USS Harry S. Truman punched deep into Yemen in a coordinated multi-wave blitz, and all of it was made possible by this new precision weapon. The success of the entire mission hinged on what happened next at 0440 local time. The first strike package flew low and silent over the Red Sea before breaking off toward their first target. SA-8 targets had been pre-plotted into their mission systems, and the aircraft split into two formations. The first zeroed in on a hardened military headquarters on the outskirts of the city that the Houthis had rebuilt from strikes 2 weeks ago. As this was going on, the second wave launched several more JSOWCs on pre-identified weapon storage sites concealed among residential blocks. A third target, the SA International Airport, was hit again to demolish patches in the airfield the Houthis had tried to fix within 5 minutes. 3 key hubs in the capital lay in smoking ruins, and it wasn't even breakfast yet. The JSOWC variant itself is a 1.65-pound device extending 161 inches in length, with a 13-foot wingspan that unfolds after being deployed. It shares the same dimensional features as earlier missiles from the JAW series, but what really distinguishes it from the rest is this. This is a 500-pound explosive, a Royal Ordnance Augmented Charge or Broach warhead. This is a key component of what makes it superior to nearly every other long-range air-to-surface missile the U.S. military has ever fielded. But that's not the full picture. The Broach stands out because of its dual-stage penetrator, and here's how it operates. Upon impact with the target, a 50-pound shaped charge embedded in the nose detonates. Inside the nose is a thin metal lining that rapidly collapses inward due to immense heat and pressure. As this lining liquefies, the missile's force directs this molten metal into a pinhead-sized jet. This miniature stream of lava is 2.5 times more powerful than the one in the traditional BLU-109 bunker buster and can pierce through steel-reinforced concrete and anything else the Houthis might be using for cover. Traveling at nearly 10 kilometers per second, this molten jet can cut through up to 3 feet of solid steel or 6 feet of reinforced concrete. Once this fiery stream breaches the outer layer, that's when the main destruction begins. In a mere 5 milliseconds, the 450-pound primary explosive follows through the narrow tunnel created by the shaped charge. After another 1 millisecond delay to ensure deep penetration, it explodes with immense force. Anyone within a 2-meter radius of the detonation point would be subjected to pressures of up to 5,000 psi, while those within 10 meters could still experience 800 psi, both well beyond survivable thresholds. And that's not the end of it. The explosion also propels around 4,500 steel shards at high velocity, capable of piercing body armor even 30 meters away. In short, whatever this missile hits is effectively eliminated on impact. By 0700 hours, the aircraft had been rearmed, refueled, and were set for the second wave. In the Omran Governorate, specifically Jabal al-Aswad, there was a communications center hidden beneath over 20 feet of solid rock, believed to house encrypted broadcast systems the Houthis were using to coordinate missile attacks. This time, the squadron launched 4 additional JSOWC missiles toward the underground facility. The strike sent shockwaves through the zone, instantly crippling all Houthi command communication systems. The precision was surgical, with laser-guided bombs navigating directly into ventilation ducts, stairwells, and fortified shelters. With no chance to regroup, the following strike commenced without delay. With a cruise range exceeding 130 kilometers, or 81 miles, the JSOWC enables the F-18 to engage from far beyond the reach of any Houthi air defense systems. Due to its high-altitude launch method, it can glide silently for several minutes before smashing into its objective with near-perfect precision, usually landing within 10 feet of the intended mark. It's essentially a sniper round dropped from a jet, made possible by some truly groundbreaking tech. What sets the JSOWC apart is its triple-layered guidance mechanism. The first is one you're likely already familiar with: GPS. After launch, the JSOWC uses a combined GPS and inertial navigation setup. Its GPS receiver connects to encrypted military satellites to chart its initial trajectory. Meanwhile, its internal inertial navigation system, INS, which includes a ring laser gyroscope and accelerometers, monitors its speed, heading, and tilt. Even if GPS signals are disrupted, this hybrid setup enables the weapon to follow a preset route over 81 miles with an accuracy radius of just 10 feet. In GPS-denied environments, the INS ensures the JC stays within 15 feet of the target. Thanks to built-in terrain-following programming and gliding control fins, it can modify its path mid-flight to avoid obstacles and use the terrain to stay hidden, making it incredibly difficult to intercept. However, this GPS-INS combo is already a system that's been in service for over a decade, previously paired with bunker busters and the entire JDAM line of weapons. What really sets the JACS apart is how it integrates two additional technologies alongside GPS. It might be hard to spot here, but located at the tip of its nose is an imaging infrared seeker. Around 30 seconds before impact, the JACC activates this seeker. It scans the terrain below and compares what it sees to a reference image of the target zone, which mission planners uploaded before takeoff. The infrared sensor's clarity is so advanced that it can tell the difference between a tank and a truck or a ship and a concealed bunker by detecting residual heat, like from a running generator. If the target is shifted slightly, the seeker can automatically recalibrate and guide the missile toward the updated position. This allows it to hit even closer than 10 feet to the bullseye. That's a huge leap over JDAMs, which are essentially blind during the final phase and depend completely on GPS coordinates that could already be outdated. By late morning, the city of Sadr came into view. 7 missile strikes, one mission, shut down the power in the region and disable every nearby Houthi military outpost. The F-18s fired off these JSOWCs from nearly their maximum range to stay out of reach from portable anti-air missiles, since the Navy had stirred up a hornet's nest earlier and was now fanning the flames. Thanks to their terminal seekers and GPS targeting, the missiles landed within 10 feet of every intended site. The strikes brought down power grids and cut off the electrical supply feeding Houthi radar systems and surface-to-air missile installations. At this point, it wasn't just about demonstrating power, it was a clear message. The U.S. was going to keep up the pressure until a ceasefire was reached. But at that moment, the mission was still full steam ahead. And the missile's capabilities don't end there. It has one last ace up its sleeve to ensure that nothing Iran supplies to the Houthis can stop it. This feature is called Link 16, a secure jamming-resistant data link that lets operators change the JC's target while it's in flight via encrypted digital signals. With this connection, airborne controllers can upload new coordinates, shift the impact point, or even redirect the missile to an entirely different objective. It's especially valuable when a high-priority or time-sensitive target is discovered after launch. Link 16 has a range of up to 300 nautical miles depending on altitude, and data transmissions are received within just 1.5 seconds. In practical terms, this means a commander aboard the USS Truman could reroute a JSOWC from a collapsing bunker to a moving command vehicle trying to escape, without the pilot needing to loop back for a second attack run. But these pilots weren't planning to give the Houthis a second shot anyway. After rearming aboard the carrier, the squadrons launched another mission that afternoon, this time heading to the Marib Governorate. There, 4 Super Hornets flew in at low altitude and took out 4 Houthi compounds they believed were secure. On the return trip, the formation dropped additional ordnance on the Houthi naval base at Al Hudaydah, destroying 3 boat launch facilities and shelters, along with at least a dozen enemy vessels. But this time, when the jets returned to the Truman, the carrier's air wing would be preparing for more than just another missile run. While the U.S. military can accomplish a great deal, it still can't hit 7 separate locations on a single fuel load. Luckily, the F-18 come with their own airborne refueling system. Each F-18 carries about 10,860 pounds of internal fuel distributed across multiple tanks embedded in its fuselage and wings. For long-range operations like this, they can attach up to 3 external fuel tanks, 1 beneath each wing and a third along the center line, adding another 8,000 pounds of fuel capacity. But even that isn't always enough to reach every target and safely return. That's where something called a buddy pod enters the picture. If you noticed, some of the F-18s on this mission weren't just carrying bombs. If you take a look under the center line of their fuselage, you'll spot the A-42R-1 buddy store refueling pod. From this pod, a 30-foot hose extends out the rear, ending in a refueling basket. To receive fuel, the trailing aircraft aligns directly behind the tanker jet, extends its refueling probe from the nose, and carefully connects with the basket. Once connected, fuel begins flowing at a rate of 1,500 pounds per minute. From the pilot's view, it's like performing a delicate dance at 20,000 feet. Both aircraft flying in close formation, adjusting throttle, wings flexing with every minor correction. During the 2 to 5 minute transfer, the buddy store system draws as much as 8,000 pounds of fuel from the donor jet's external tanks, with a max flow rate of up to 2,000 pounds per minute. And this all happens just 75 feet apart while traveling at speeds of 250 knots. This system increases the F-18's combat range from around 450 nautical miles to over 700, depending on mission load and flight profile. It enables them to fly deeper into hostile territory, stay on station longer, and get back without depending on Air Force tankers. But it does come with trade-offs. Flying as a tanker adds drag, slows down the aircraft, and limits how many weapons it can carry. And any misalignment during the hookup could rip off the probe or damage the hose entirely. It's a risk, but one the Navy is willing to take because it keeps the mission moving forward. By that evening, the strike group had nearly reached the Saudi border near Saad. 2 F-18 aircraft equipped with Pavway bombs flew overhead and dropped their munitions on known ammunition depots scattered through the countryside. Meanwhile, the remaining 6 F-18s broke off to hit their primary target, Hazam City. There, 12 precision strikes lit up the area like the 4th of July came early. 3 Houthi military installations, 2 separate ammunition storage facilities, and 1 reinforced bunker complex were completely destroyed. Without the buddy store aerial refueling, none of this would have been possible, not across such wide terrain and certainly not at this relentless pace. Bye for now.